Hello friends, so we meet again. In our last discussion on images, we talked about graphical approach, we learned the art of organizing the tools, then we discussed why we should have two monitors connected to a multimedia workstation, and lastly we learned what bitmaps are, where to get them and how to manipulate them. In today's lecture, we will talk about vector graphics and 3D images and describe the capabilities and limitations of vector graphics and 3D images. Then we will discuss the use of color in multimedia and then cite the various image file types used in multimedia. So, we start with vector drawing. Most multimedia authoring systems make use of vector drawn objects such as lines, rectangles, ovals, polygons and text. Computer aided design programs have traditionally used vector drawn object systems for creating the highly complex and geometric renderings needed by architects and engineers. Graphic artists designing for print media use vector drawn objects because the same mathematics that put a rectangle on your screen can also place that rectangle on paper without pixelation. A vector is a line that is described by the location of its two endpoints. Vector drawing uses Cartesian coordinates, where a pair of numbers describe a point in two-dimensional space as the intersection of horizontal and vertical lines, that is the x and y axis. The numbers are always listed in the order x and y. In three-dimensional space, a third dimension, depth, is described by a z axis, that is x, y and z. So, a line might simply be represented as shown here, where x1 and y1 define the starting point and x2 and y2 define the end point. Vector drawn objects versus bitmaps. Vector drawn objects are described and drawn to the computer screen using a fraction of the memory space required to describe and store the same object in bitmap form. A vector drawn object is created on the fly, that is, the computer draws the image from the instruction it has been given rather than displaying a pre-created image. This means that vector objects are easily scalable without loss of resolution or image quality. A large drawn image can be shrunk to the size of a postage stamp, and while it may not look good on a computer monitor at 72 dpi, it may look great when printed at 300 dpi to a color printer. Resizing a bitmapped image requires either duplicating pixels or throwing pixels away and eliminating details. Because vector images are drawn from instructions on the fly, a rescaled image retains the quality of the original. Converting between bitmaps and drawn images. Most drawing programs offer several file formats for saving your work, and if you wish, you can convert a drawing that consists of several vector drawn objects into a bitmap where you save the drawing. You can also grab a bitmapped screen image of your drawn objects with the screen capture program. Converting bitmaps to drawn objects is more difficult. There are, however, programs that will compute a bitmapped image or the shapes or colors within an image and then derive the polygon object that describes the image. This procedure is called auto tracing and is available in vector drawing applications such as Illustrator or freehand. Flash has a trace bitmap menu option that converts a bitmapped image into a vector image. 3D drawing and rendering. Drawing in perspective or in 3D on a two-dimensional surface takes special skill and talent. Dedicated software is available to help you render three-dimensional scenes, complete with directional lighting and special effects. But be prepared for late nights and steep learning curves as you become familiar with deformations, mesh generations, and skinning. For making 3D text to creating detailed walkthroughs of 3D space, each application will demand study and practice before you are efficient and comfortable with its feature set and power. The production value of multimedia projects have increased dramatically, and as the production bar has risen and users' expectations have also gone upward. Today, many products like DAS 3D and Form Z are touted as essential tools for illustration, animation, and multimedia production. Nutex Lightwave and Autodesk's Maya and 3D Studio Max are industry standard high-end animation programs used for everything from multimedia programs and game designs to special effects in films and even feature-length movies. For experimenting with 3D, Google's SketchUp provides a simple and free tool. To go deeply into 3D, the open source Blender is a powerful tool, but its complex interface presents a steep learning curve. For 3D, the depth, that is Z dimension, of cubes and spheres must be calculated and displayed so that the perspective of the rendered object seems correct to the eye. As illustrated in figure, most 3D software packages provide adjustable views so that you can see your work from the top, bottom, or sides. A great deal of information is needed to display a 3D scene. Scenes consist of objects that in turn contain many small elements such as blocks, cylinders, spheres, or cones, described using mathematical constructs or formulas. The more elements contained in an object, the more complicated its structure will be. Objects and elements in 3D space carry with them properties such as shape, color, texture, shading, and location. A scene contains many different objects. Objects are created by modeling them using a 3D application. To model an object that you want to place in your scene, you must start with a shape. You can create a shape from scratch, or you can import a previously made shape from a library of geometric shapes called primitives. Typically, blocks, cylinders, spheres, and cones. In most 3D applications, you can create any 2D shape with a drawing tool or place the outline of a letter, then extrude or lathe it into the third dimension along the Z axis. When you extrude a plane surface, its shape extends some distance either perpendicular to the shape's outline or along a defined path. When you lathe a shape, a profile of the shape is rotated around a defined axis to create the 3D object. To model a scene, you place all of your objects in 3D space. Then you can add a background and set a camera view, the location and angle from which you will view the final rendered scene. When you have completed the modeling of your scene or an object in it, you must then render it for final output. Rendering is when the computer finally uses intricate algorithms to apply the effects you have specified on the object you have created. Figure here shows a background, an object, and the rendered composite. Rendering an image requires great computing muscle and often takes a lot of time for a single image, and you will feel the strength or weakness of your hardware. Indeed, some multimedia and animation companies dedicate certain computers solely for rendering and are called render farms. The final images for the classic animated movie Toy Story were rendered on a farm with huge muscle power comprising of 87 dual processor and 30 quad processor Xeon workstations. It took 46 days of continuous processing to render that film's 1 lakh frames at a rate of about 1 frame every 1 to 3 hours. Panoramas. Media players such as QuickTime and Real Player let you view a single surrounding image as if you were inside the picture and able to look up or down, turn or zoom in on features. To make this work, you need to stitch together many images taken from a different angle around a circle. Softwares such as ULEAD Cool 360 or Panorama Factory works by importing a sequence of photos and letting you adjust them precisely into a single seamless bitmap. You should allow some overlap when you take each photo for a 360-degree panorama, and while stitching you may need to adjust each photo's contrast, brightness, hue and saturation. Most programs also allow you to adjust perspective to compensate for different focal lengths or camera heights. Color. Color is a vital component of multimedia. The next discussion will explain where color comes from and how colors are displayed on a computer monitor. Management of color is both a subjective and a technical exercise. Picking the right colors and combinations of colors for your project can involve many tries until you feel the result is right. But the technical description of a color may be expressed in known physical values. Humans, for example, perceive colors with wavelength ranging from 400 to 600 nanometers on the electromagnetic spectrum. Several methods and models describe color space using mathematics and values. Understanding natural light and color. Light comes from an atom where an electron passes from a higher to a lower energy level. Thus, each atom produces uniquely specific colors. This explanation of light, known as the quantum theory, was developed by physicist Max Planck in the late 19th century. Niels Bohr, another physicist, later showed that an excited atom that has absorbed energy and whose electrons have moved into higher orbits will throw off that energy in the form of quantas or photons when it reverts to the stable state. This is where light comes from. Color, on the other hand, is the frequency of light wave within the narrow bandwidth of electromagnetic spectrum to which the human eye responds. Light that is infrared or below the frequency of red light and not perceivable by human eye can be created and viewed by electronic diodes and sensors, and it is used for TV and VCR remote controls, for wireless communications among computers, and for night goggles used in the military. Computerized color. Because the eye's receptors are sensitive to red, green and blue light, by adjusting combinations of these three colors, the eye and brain will interpolate the combinations of colors in between. This is the psychology, not the physics of color. What you perceive as orange on a computer monitor is a combination of two frequencies of green and red light, not the actual spectral frequency you see when you look at an orange in sunlight. Although the eye perceives colors based upon red, green and blue, there are actually two basic methods of making color: additive and subtractive. And first we will talk about additive colors. In the additive color method, a color is created by combining colored light sources in three primary colors: red, green and blue. This is the process used for cathode ray tube, liquid crystal and plasma displays. On the back of the glass face of CRT are thousands of phosphorescing chemical dots. These dots are each about 0.3 mm or less in diameter and are positioned very carefully and very close together, arranged in triads of red, green and blue. These dots are bombarded by electrons that paint the screen at high speeds at about 60 times a second. The red, green and blue dots light up when hit by the electron beams. Your eye sees the combination of red, green and blue light and interpolates it to create all other colors. Like CRTs, LCD and plasma screens utilize tiny red, green and blue elements energized through tiny transparent conductors and organized in Cartesian grid. Subtractive color. In the subtractive color method, color is created by combining colored media such as paints or ink that absorb or subtract some parts of the color spectrum of light and reflect the others back to the eye. Subtractive color is the process used to create color in printing. The printed page is made up of tiny half-tone dots of three primary colors, cyan, magenta and yellow, designated as CMY. Four-color printing includes black, which is technically not a color, but rather the absence of color. Since the letter B is already used for blue, black is designated as K. So, four-color printing is designated as CMYK. The color remaining in the reflected part of the light that reaches your eye from the printed page is the color you perceive. All these factors make computerized color pretty tricky to manage. High-end image editing programs such as Photoshop deal with this problem by allowing you to calibrate your monitor with your printer. Image file formats. Most applications on any operating system can manage JPEG, GIF, PNG and TIFF image formats. An older format used on the Macintosh, PICT, is a complicated but versatile format developed by Apple, where both bitmaps and vector drawn objects can live side by side. The device independent bitmap DIB, also known as BMP, is a common Windows palette based image file format similar to PNG. PCX files were originally developed for use in ZSoft MS-DOS paint packages. These files can be opened and saved by almost all MS-DOS paint software and desktop publishing software. TIFF or tagged interchange file format was designed to be a universal bitmapped image format and is also used extensively in desktop publishing packages. Often applications use a proprietary file format to store their images. Adobe creates a PSD file for Photoshop and an AI file for Illustrator. Corel creates a CDR file. DFX was developed by Autodesk as an ASCII based drawing interchange file for AutoCAD, but the format is used today by many computer aided design applications. IGS or IGES for Initial Graphic Exchange Standard was developed by an industry committee as a broader standard for transferring CAD drawings. These formats are also used in 3D rendering and animation programs. JPEG, PNG and GIF images are the most common bitmap formats used on the web and may be considered cross-platform, as all browsers will display them. Adobe's popular PDF file manages bitmaps and drawn art as well as text and other multimedia content, and is commonly used to deliver a finished product that contains multiple assets. So, this brings us to the end of our discussion, and therefore, we sum up. Bitmaps are an image type most appropriate for photorealistic images and complex drawings requiring fine detail. Limitations of bitmapped images include large file sizes and the inability to scale or resize the image easily while maintaining quality. A bitmap is a simple information matrix describing the individual dots of an image called pixels. Vector images are most appropriate for lines, boxes, circles, polygons, and other graphic shapes that can be mathematically expressed in angles, coordinates, and distances. A vector object can be filled with color and patterns, and you can select it as a single object. Vector drawn objects use a fraction of the memory space required to describe and store the same object in bitmap form. For 3D, the depth of cubes and spheres must be calculated and displayed so that the perspective of the rendered object seems correct to the eye. Objects and elements in 3D space carry with them properties such as shape, color, texture, shading, and location. To model an object that you want to place into your scene, you must start with a shape. Windows uses device independent bitmaps as its common image file format, usually written as BMP files. Tagged interchange file format was designed to be a universal bitmapped image format and is also used extensively in desktop publishing packages. So, that is it for today. See you in next lecture. Thank you.